Ever wonder how a game just knows you've leveled up? Or how your email app can magically sort your mail? Well, it isn't magic, it's just code making smart decisions. And today, we're going to pull back the curtain and see exactly how Python gets it done. Let's get into it. So when you see a wall of code like this, it's easy to think of it as just a simple to-do list for your computer, right? Just run this, then this, then this. But that's not really how it works. Modern code is way more interesting. It's more like a choose-your-own-adventure story with all these different forks in the road. And that's the big question, isn't it? If the code isn't just a straight line, how in the world does it know which path to take? What's the secret sauce that lets it make all these choices? Well, that is exactly what we're about to find out. Turns out it all comes down to a really simple map, kind of like this flowchart here. And at every single fork in the road, the code asks itself a super simple question that only has two possible answers. Is this true or is it false? That's it. Every single complex decision boils down to that one little choice. And this little test, this question, it has a name. We call it a condition. And you've got to understand this is the absolute heart of every single decision your code makes. Is the player's health less than 0? True or false? Is this email marked as spam? True or false? That simple answer is what drives everything. Now, these true and false values are actually a special data type called a Boolean, and a really good way to think about them is like a referee's flag in a sports game. When that flag goes up, it's a signal, right? It's true that a penalty just happened. In your code, a true value is the exact same thing. It's a flag that tells the program, hey, this thing you were watching for, it just happened. Okay, so that's the big idea. But how do we actually, write this? How do we tell Python to make one of these decisions? Well, it all starts with one tiny but incredibly powerful keyword, if. And the structure for this is actually really clean. You just type if, then you write out your condition, the question you're asking. And you always end that line with a colon. That colon is so important. Think of it like a little drum roll that tells Python, okay, pay attention. What I'm about to tell you to do only happens if this condition is true. And this brings us to something that is absolutely critical in Python, indentation. You see those spaces at the start of the line? They're not just there to look neat. They are the rule. Indentation is how you tell Python which code belongs to that if statement. It's the visual cue that says, hey, all of this indented stuff, it's one block. Run it all together if the condition is true. All right, let's look at a real example. Check out this code. We ask the user if they want to hear a joke. Then, our if statement checks their answer. So, if the user types in the word yes, all lowercase, what do you think is going to happen? If you said it tells the joke, you nailed it. The code checks if the variable user choice is equal to yes. The condition is true, so it runs the indented code and prints the punchline. But notice this. If the user types no, or even yes in all caps, the condition is false. And nothing happens. The program just ends. Kind of boring, right? Yeah, that joke program isn't very helpful if you say no. We need a way to give the code a plan B, something to do when the if condition isn't true. And for that, we have another keyword, else. Okay, look at the difference here. On the left, we've got a simple if. If the value is less than 10, it prints tortoise. Otherwise, nothing. But on the right, we've added an else block. Now, if the if condition is false, the code doesn't just stop, it runs the else block instead and prints hamster. It's a built-in backup plan. All right, pop quiz time. Look at this code. We set a variable called value to exactly 10. Then the if statement checks if that value is less than 10. So, is that condition true or false? And based on that, what do you think this code is going to print? And the answer is hamster. You got it. Since 10 is not less than 10, the if condition is false. So Python completely skips the tortoise part and jumps right down to the else block, running that code instead. It's the perfect fallback. So if is our plan A, and else is our plan B. But what if you need a plan C and a plan D? Real life has more than two options, and so does good code. And that's where our next tool, elif, comes into play. Elf is just a cool, short way of saying else if. It lets you chain a bunch of checks together, one after another. Python starts at the top with the if and checks the condition. If it's false, it moves to the first elf. If that's false, it moves to the next elf, and so on. But here's the key. The very first time it finds a condition that's true, it runs that code, and then it's done. It completely skips the rest of the chain. It's kind of like picking a can of paint. You know you want the blue one. You look at the first can. Is it blue? Nope, it's red. So you check the next one. Is this one blue? Yep, so you grab it and you'll walk away. You don't even bother looking at the yellow and green cans because you already found what you needed. That's exactly how elif works. It finds the first right answer and moves on. So you can build this whole ladder of logic. First, check if the score is over 1,000. If not, elif the score is over 500. If not, elif the score is over 100. And if none of those are true, the final else can handle everything else. It's a super clean way to handle a whole range of possibilities. Okay, you now have the big three: if, elif, and else. You can build some really powerful logic with these. But before you go wild, let's go over a few of the most common mistakes that trip people up. Think of this as your quick guide to avoiding headaches. Mistake number 1, and this is the absolute classic: using a single equals sign instead of a double equals. Remember, a single equals is for assigning a value. It means put this thing in this box. A double equals is for comparing. It asks, are these two things the same? If you mix them up in an if statement, you're going to have a bad time. Mistake number 2 is forgetting the colon. I know, it's a tiny little dot, but in Python, it's everything. That colon at the end of an if, elif, or else line is a non-negotiable signal. It tells Python, hey, a block of code is about to start. Without it, Python just gets confused and gives you an error. And of course, we have to talk about indentation again. The if, elif, and else keywords themselves have to line up with each other. And then, the code that belongs to each of them has to be indented underneath. This structure isn't optional. It's how Python understands the logic of what you're building. And finally, remember the one else rule. For any if statement, you can have as many elifs as you want, but you can only have one final else block. It's the end of the line, the ultimate catch-all. You can't have two different default options. So now you've got the tools and you know the rules. It's time to put it all together. Take a look at this really simple number guessing game. Right now, it just tells you if you're right or wrong, but you can make it way better. So here's your challenge. How would you use what you've just learned to upgrade this code so it tells the player if their guess is too high or too low? Think about it, give it a shot, and start making your code a little bit smarter. Happy coding!